Question came up on the Cisco Learning Network over the weekend, and the question was about discontiguous networks, and the real question was trying to understand the difference between a discontiguous network and a discontiguous address space. And I wanted to take a moment and try to explain my perspective on this and try not to add any additional confusion. But I think there's overlap in the terminology for sure. Let me give another example. We could say, can you tell me the difference between a red car and a car? A red car is still a car. A car might not necessarily be a red car. So a simple way I would say this is when we're talking about contiguous and discontiguous networks, is that a network is an address space. An address space might not necessarily be specifically a network based on the classical rules that we assume when we see it in that context. So here's some examples of what I would consider a network. So again, when we're talking about we see the keyword network, and we're seeing it in the context of this. A lot of routing protocols look at things based on default summarization based on classical rules and things like that. So the classical rules, we define those in RFC 791, and we have class A, class B, class C. And like network 10.0.0.0 is an example of a class A network address. It happens to be an RFC 1918 address, but that's really irrelevant for the sakes of conversation. But when we see that without any subnet mask, we assume that /8 subnet mask, or 255.0.0.0, depending on how you write your subnet mask. So we're looking at an IP address range, or not necessarily a host range, but a total range of 10.0.0.0 through 10.255.255.255. We can have the exact same example for a non-RFC 1918 address range. So network 8.0.0.0 would be an example of something that's not RFC 1918. Again, same strategy for figuring out the range, 8.0.0.0 through 8.255.255.255. And then we can look at, network 172.16.0.0. We assume class B, based on classical rules defined in RFC 791, and we're looking at the range of 172.16.0.0 through 172.16.255.255. And then a class C example of a network would be 192.168.0.0 through 192.168.0.255. So that would be a class C version of a network. So when we're talking about contiguous and we're talking about discontiguous networks, what we're talking about is whether networks are together or networks are apart. So again, we talked about 10.0.0.0 being a network. So if we look at that as a network, that's a class A network based on the original RFC for that. We can see that all the components that are represented in this network are together. So 10.110 through 10.550, they're not separated by anything that's outside of that address range. If they were separated by something that was outside of that address range, then we would call that discontiguous. It's separated. So if I make this this network in the middle, if we convert this from a 10 network to 11 network, so again, it is now these two subcomponents of the 10 network are separated from 10.4.4.0 and 10.5.5.0 by a network that is part of, or a subnetwork in this case, that's part of a different network range. It's outside of this. So we would call this discontiguous. again, if all the components in the path from point A to point B are part of the same network, we would say it's a contiguous network. If it's not, we would say it's a discontiguous network. And now let's expand the topic of discontiguous and contiguous beyond just networks, and we'll look at address spaces and how we define those. So I would say that we can define an address space when we're talking about IP address spaces. We can define them in the following ways. We can do a classful network. Again, we had classful networks. We saw that. That was the example that we just went through. So again, a red car is still a car, but a car is not necessarily a red car. And the same thing here. A contiguous or a discontiguous network can be a contiguous or discontiguous address space, respectively, obviously. But a contiguous address space may not necessarily be a contiguous network, and a discontiguous address space may not necessarily be a discontiguous network. If I said that correctly, so discontiguous address space may not necessarily be a discontiguous network, because we're basically expanding on the rules of what we're looking at and the perspective. So another way that we could define an address space would be a supernet. So we could say 10.0.0/7. That aggregates the 10 network and the 11 network together into one supernet. So now our address space is 10.0.0.0 through 11, 255, 255, 255. And then we could also do it, we could take a subset of a network. So we could say the 10 network is actually subnetted, and we're going to look at this through the lens of the 10.199 subnet, and we're going to have some smaller subnets that we build around our network, but we're going to look at the contiguous versus discontiguous argument based on this address space here. And we'll take a quick look at how that would work in a topology as well. So first thing, let's go ahead and let's say that we're going to use this address space. It's a supernet. So now we've created this address space, and we're saying we're looking at it through the lens of a 10.0.0.0/7 address space. So notice that's not a network, it's actually two networks that we've created an address space out of. And if we look at this network, let me back up for a second. So the question really should arise, so where do we get this? There's two ways that we would actually get this if we're having this discussion. The first way would be that it's given to us. So somebody, test question, something like that has given us this address space and said, you know, this is the address space. Can you tell me if any of these components are discontiguous in regard to that on this network? And then we would have that given to us. The second way that we would get this is actually probably more realistic, and that's if we were actually designing a network and working out a summarization strategy, and we were looking at an area of the network and seeing sort of what fit in that area of the network, and then trying to determine if there are any discontiguous components. So there's two ways we would get it. One is if it's given to us, and the other is studying a network topology, network design for summarization purposes. So let's go back here and back on this example now. So we've got the 10.0.0.0/7 address space, and now we actually can see that we have a contiguous address space. So all of these are part of the same address space because we've identified the address space like that. So anything 10 anything to 11 anything, and all of these components fit within that. So if we had, and just to make things a little bit more interesting, I'm going to go ahead and change this from 10. We're going to change it to 11. we still have a contiguous address space, but I wanted to make sure that we had clarity when we show a discontiguous example. So if I change this to 13, now all of a sudden these two address components, which are part of this address space, are separated from these two components of this address space by something that's outside of this address space. So I would say we have a discontiguous address space here. Now we can also take and use a subnet example. So instead of actually aggregating two networks together, we actually may have a smaller portion of a major network. So in this case, we're going to say we're going to use the 10.199.0.0/16 subnet. That's part of a Class A network, and the range that we're looking for is 10.199.0.0 through 10.199.255.255. And again, that's based on what's been given to us or what we've determined based on our analysis of a network topology. I'm going to go ahead and we're going to make this network contiguous again. We're going to go 10.199.1. We're going to go 10.199.2. If my mouse will 10.199.3. 10.199.4, 10.199.5. Okay, so now you can see that we have a contiguous network once again because all of the components that we've identified fall within that same address range. So there's nothing on the left side of the network or the left side of the diagram that traverses something that falls outside of the range. Now if I change this to 10.200, so now we actually have what I would consider a discontiguous address space if we're looking at it based on this. So 10.199.1 and 10.192 are separated from 10.199.4 and 10.199.5 by something that falls outside of the range. In this case, 10.200.3. Now, this could actually be a contiguous network, but a discontiguous address space, because from a networking perspective, all of this falls inside of the 10.0.0.0 Class A network. But since we either looked at our network diagram, our network topology, in the case of building the summarization strategy, or we've been told to look at this from a /16 perspective, it is definitely not contiguous. So this would be we would call it a we'll say discontiguous address space, or we could say a 10.0.0.0 contiguous network. So I think that's the moral of the story here is that we're looking at things through a lens, and we've got to figure out what lens we're looking at it through. And the term network gets used very loosely. I'm guilty of it. I think pretty much everybody is. So it's always worth getting clarification if you're looking at it from a classical perspective or just generally using the term, because it's very easy to go into these conversations and find that people would call this they may call the 10.199.00 a network, but when we actually are talking about it in terms of a network versus an address space, or a contiguous network versus a contiguous and network address space, or contiguous address space, just the term network alone, we probably need to make clarify, but it typically would mean that we're talking about classical rules. So just wrapping up here, I would say that a network, we assume classical. An address space could be a classical network, a supernet, or a subnet. And again, when you hear somebody saying network, it might be a good idea to go ahead and determine if you're talking about classical rules, which might be a more typical way that you'll see this from CCNA, CCNP study perspective. But in the real world, when you're outside of the testing environment and the strict terminology terms that we use around those, you'll actually just hear people fairly generically throw the term around there. So again, an address space could be a classical network, a supernet, or a subnet. Hope this helps. Certainly hope it's not created additional confusion. If there's any questions, feel free to respond in the Learning Network thread, and we'll try to keep the conversation going until we clarify this and we're all sort of in agreement on have a great